Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 9 of a unit Laws of Motion. In today's class we are going to discuss about the numericals of common forces and mechanics. So if you have not revised all the forces that we have discussed up till now, that includes a weight, then the normal force, then the tension, and at last we were discussing with the frictions. So if you have not revised this units, if you have not revised this topics, please go through that, revise those topics and come back to this session. If you have did it, well done. Let's be ready with your pen and paper and start doing the questions. Let's have a look what question is saying. It says a body of mass 2 kg is slipping on a frictionless, having no friction, a frictionless horizontal table with a velocity of 4 meter per second. The necessary force in Newton to keep the body moving with the same velocity. So the situation could be something like this, that a body of mass 2 kg is there and it is moving, it is slipping on a table with a speed of 4 meter per second. What do you want? You want to find out the force so that this block can continue moving in its own motion. So if you remember the Newton's first law, what was it? Newton's first law. It says that if an object is at rest or moving with uniform velocity, then object will continue to be in its own state unless any external force is acting on that. So go through the data one more time. Go through the data one more time and let me know that does this block is having any of the force acting on it? Look at this, it is a frictionless surface, so it is not having any force. Yes, and it is moving in horizontal direction. So according to the Newton's first law, the force required would be the 0 Newton. That's it. Yes, we must understand Newton's first law, second law, third law very carefully. Let's walk for the next question. Let's have a look what question is saying. It says an eraser weighing 2 Newton is pressed against the blackboard with a force of 5 Newton. So it must be something like this, that this must be the eraser and its weight is given. So mg of this is 2 Newton and is pressed against the blackboard with a force of 5 Newton, something like this. The coefficient of friction, okay, this is with friction, this mu is equals 2.4. How much force parallel to the blackboard is required to slide the eraser in upward direction? You want that eraser should move in upward direction. This is F external, that is what you require. So what can you do? One more thing, if F external is acting on upward direction and you want that your eraser should be moving in the upward, that means your force of friction should be acting in the downward direction. So what you want to do is your F external should be equals to or greater than F plus mg. If it should be greater than or equals to, if it is there, then eraser can move in upward direction If it is the case, then eraser can move in the upward direction. This was the case. So now what we can do? So let's just find out the friction force. So the situation is, this is the F with which it has been pressed. This is F external we are looking for. This is the mg and this is the friction. So friction F would be, maximum value of friction would be equals to mu s into n, and this would be the friction. This would be the normal, sorry. This normal and this force would be the equal. Mu, it's a 0.4, which is 4 by 10 multiplied by normal force, and that normal force would be 5. It's a 4 5s are 20, 20 by 10, that would be equals to 2 Newton. So even friction force is of 2 Newton. Weight they have given in the data that it is of 2 Newton. So F external required to move the block in the upward direction is 2 plus 2, which should be a 4 Newton. That's it. You did it. Great job. Do you have the same answer? Do you? Great. Ready for the next question? Are you ready? Let's have a look. What does it says? A very good question. It says a box weighing 500 Newton. Okay. So this mg is 500 Newton. Is at rest on a horizontal floor. A force of F, which is of 200 Newton, is applied at an angle of 30 degree with horizontal as shown in the figure. The coefficient of kinetic friction if the box is moving with constant speed. Okay, so how could you do this? First, let's understand that this is 200 Newton, this is 200 cos 30 degree, and in this direction it's a 200 sin 30 degree. Yes, as it says that it is at rest on horizontal floor. So when it is at rest, that means a total horizontal force applying on the block is equal. That means total forces applying in positive x direction must be equal to the total forces applying in the negative x direction. Same is true for the vertical direction as well. So what we need to do is, it's a 200 cos 30 degree should be is equals to friction, and from this we can have a value of a mu k. It's because it's a coefficient of kinetic friction. So this is mu k multiplied by normal. This is 200 cos 30. This is cos, and cos 30 would be equals to root 3 by 2. So that could be equals to mu k multiplied by n, that is equals to 100 multiplied by root 3. Yes, is it clear? Is it? Now how could you find out the normal force? Because here in the vertically upward direction two forces are there. One is the normal and another is the 200 sin 30, and in the vertically downward direction it is the weight of a box. So it is n plus 200 sin 30 degree should be is equals to 500. So this is n plus 200 sin 30 is half, that would be equals to 500. This is n plus 100 should be is equals to 500. That means normal force should be equals to 500 minus 100, it's a 400 Newton. I hope this is clear. Now let's just replace the value, that mu k into n, that should be is equals to 100 multiplied by root of 3. Now mu k, that we have got it, it's a 400. This is equals to 100 multiplied by root of 3. So mu k, it's a coefficient of kinetic friction, would be equals to 100 by 400 multiplied by root of 3. It will be root of 3 divided by 4. So this is the coefficient of kinetic friction. This would be the answer. Yes, very good question. Yes, there are chances that we are going to forget this 200 sin 30 while calculating the n. It is probable, probability would be there And that's why this kind of questions has been asked, so that they are making an angle of certain angle with horizontal, or even this is possible with certain angle with vertical as well. But please keep in mind that when object is at equilibrium, that means all the forces acting on the object is zero. That means you need to carefully consider each and every force that is acting on an object. I hope this is clear. It is? Great. Let's work for the next question. What does it say? It says a force of 1200 Newton is applied on toy car of mass 1000 kg. If the coefficient of friction is 0.03, then the acceleration of the car. Yes, this is what they have asked, that it's a toy car is there, and this toy car is of 1000 kg, and a force of 1200 Newton is applied. Let's suppose it's a force of 1200 Newton. What I want the acceleration of the car, and the coefficient of friction is given. This is given, that is equals to mu is equals to 0.03. So what I want the acceleration of the car. How should I do this? How should I do this? What could be done? What could be that? Let's have the value. This is 1200 Newton force, and this would be the direction of friction, because I have assumed it. I have assumed that my object is moving in the positive x direction, so that should be is equals to 1200 Newton minus of friction should be is equals to mass into acceleration. So that should be is equals to 1200 minus of mu. Mu could be F could be written as mu. This is the normal force. This is the mg. So this is N is equals to mg. Yes. So this is equals to 1000 into 10. It's a 10,000. And this is mu into N should be is equals to mass into acceleration. So this is 1200 minus of mu. Mu is of 0.3. This is 3 divided by 100 multiplied by N. It's a 10,000 should be is equals to 1000 multiplied by acceleration. So this 2 has gone. This 2 has gone. So it's a 1200 minus of 300. It's a 1200 minus of 300. And when I go for it, it's a 1200 minus 300. So let's have a look. It's a 1200 minus 300 is equals to 1000 into acceleration. So 1200 minus 300, it's a 900 divided by 1000. That should be equals to acceleration. This 2 has gone, this 2 has gone, and the A would be equals to 0.9 meter per second square. This would be the answer. I hope this is clear. Is it clear? What was your answer? Is it same? Is it? Great work. Let's move to the next question. What does it say? Is a force of 200 Newton gives a body an acceleration of 1.5 meter per second square, but a force of 300 Newton gives the same body an acceleration of this. The mass of the body is okay. So the situation may be something like this, that this is F external. This must be the direction of friction. This must be the direction of friction. And in the first case, force 1 was of 200 Newton. And due to this, the acceleration was 1.5. In the second case, it's a force 2, which would be of 300 Newton. And the acceleration 2 would be equals to 2.5. Now, what I want the mass of the body. How should I get it? So what I can do is that this is 200 minus of F. 200 minus F is equals to mass into acceleration. This would be the first result. And second result, it's a 300 minus F is equals to mass multiplied by acceleration. It's a 2.5. I hope you can solve this. Yes, even multiply this second with the negative. It's a minus, it's a plus, it's a minus. So this friction has gone, and you can do the rest of the task. It's a 200 minus 300. It's a 100. And this is 1.5 minus 2.5. It's a minus of 1.5, minus minus plus. It's a 100 kg. That's it. Yes, yes. It was beat easy. Yes. Let's work for the next question. Do it quickly. Time is running. Make it fast. A block of mass 5 kg rest on a horizontal surface. If a force of 25 Newton is applied on the body, changes its velocity to 8 meter per second. That means it is at rest initially, and now it is moving with the speed of 8 meter per second in 2 seconds. Okay, even time is given. Then the frictional force acting on the block. Yes, what do we understand? We understand that M into A should be equals to F external minus of friction force. A could be written as V minus U by T, but as I understand that U is 0, that's why I have written only V by T. So this is 5 multiplied by V, which is 8 minus of 0 divided by time, which is equals to 2. That should be is equals to F minus of F. Frictional force I require. I have applied an external force of 25 Newton. So this is 25 minus of friction. Is it clear? Yes. So this is equals to 5 8s are 40, 40 by 2. It's a 20 is equals to 25 minus of F. So this friction force should be equals to 25 minus of 20. That would be equals to 5 Newton. That's it. You did it. Great job. Yes. Ready for the next question? Ready? Let's move on. Go for this. What does it say? A block of mass 5 kg lies on a rough horizontal plane. When it write down the word, it's a rough plane. That means it is moving on the surface with friction. A force of 19.6 Newton is enough to keep the body sliding at a uniform velocity. Calculate the coefficient of sliding friction. Okay, great. So something like this. This is a block of 5 kg and a force of 19.6 Newton is there. A friction must be acting over here. As it says that this force of 19.6 Newton is enough to keep the body sliding at uniform velocity. Look at this. This is not an accelerated motion. This is a motion of uniform velocity. And when it is a motion of a uniform velocity, that means net force acting on this block should be a 0. And when it is the situation, what I can write, it's F is equals to ma. This friction should be equals to mu s multiplied by mg in this case, and this force, it is a 19.6 Newton, must be there to balance the friction acting on the block. So this is ma should be equals to mu into mg. This mass has gone. And A could be written as mu into G. Now what I want a mu. So mu should be is equals to A divided by G. Acceleration is given? No, it is not given, but a force and mass both is given, so it is sufficient. It's a 19.6 divided by 5, and I can write G as a 9.8. This is 9.8, 2s are 19.6. This is 2 by 5, which is 0.4. It does not have a unit because it is a ratio of the forces. So coefficient of sliding friction, it's a mu, and whose value could be mu is equals to 0.4. Is it clear? Is it? Yes. Great. Let's work for the next question. it is all about. It says a body can travel on a rough plane with a retardation equal to 1/4 of acceleration, okay, due to gravity. The coefficient of friction in the last numerical only we have derived this. A is equals to mu into g, and according to the data that a body can travel on a rough plane with retardation which equals to 1/4 of the acceleration. So A should be equals to g by 4. This g by 4 should be equals to mu g. This g has gone, and this mu is equals to 1 by 4, which is 0.25. I hope this is clear. Is it clear? Is it? Are you sure? Any issues? Any doubts? Anything in this? No? Great. So now let's work on the next question. Let's suppose this is a block of mass 10 kg, and at any instant it is moving with a speed of 40 meter per second. This path is having a friction, and the coefficient of kinetic friction mu has been given, and mu on this path is of 0.4. So now the question is, find out time required by this block to stop. I want to find out the time required by this block to stop. Now the question is, why this will stop? Because it is already moving with 40 meter per second. This path is having a friction, so this friction will be in the opposite direction to the direction of natural tendency of motion. So this is moving in positive x direction. I should apply a friction in the negative x direction. So what happens? This friction will oppose the relative motion between this block and this surface. So it is going to stop at certain instant of time. I need to find out that time only. So what I can do is, let's look at this very carefully, that because this is the basics and these are the concepts. This is n, this is mg. What you can do is that F external could be written as mass into acceleration. This friction could be written as mu into m into g. This both can be equated, so m into a could be written as mu into m into g, and this 2 has gone. That is equals to a could be written as mu into g. So every time when block is moving, shall I write this? Yes. So when block is moving on straight road, acceleration can be replaced by a is equals to mu into g. And when I can write a equals to mu g, it is something like this, that it is moving with a speed of 40 meter per second and friction is acting over this. So this is v minus of u is equals to a into t. This should be 0 minus of u. It is a 40 meter per second. A, as it is retarding, that's why I write it. It's a mu into g multiplied by t. This minus positive. It's a 40 is equals to, what is mu? Yes, it's a 0.4. Should be a 4 by 10 multiplied by 10 multiplied by t. This 2 has gone, and t should be is equals to 40 by 4, which should be 10 seconds. That means block will stop. Block will stop after traveling a distance of 10 seconds. I hope this is clear. Is it clear? So Shall you do one more question related to this only? And the previous question. In the previous question, find out distance traveled by block before coming to rest. So how can you do this? How can you do this? What I understand is that I am having an final velocity which is v equals to 0. I am having an initial velocity which is equals to 40 meter per second. I am having an acceleration which is equals to mu into g. Now even I am having a time that is of 10 seconds. What I want x. So I can go with this. It's a v square minus of u square, that should be is equals to 2 into a into x. The final velocity is 0, initial is 40, this is 1600, that should be is equals to minus of 2 into a. A would be equals to mu into g. Mu is 0.4, it's a 4 by 10 multiplied by 10 multiplied by x. This 2 has gone, this 2 has gone, and this 10 has been cancelled out. So this is equals to 1600 is equals to 2 4s are 8 into x. So this is x, that is equals to 1600 by 8, which should be 200 meter. So the object will stop after traveling a distance of 200 meter. I hope this is clear. Is it clear? Great. Let's look at this question. The question says that suppose one of the wage is given and this is the angle theta, and let's say suppose a block is there, block is having mass m, and this wage is having a friction, and that is of u mu. Let's say this block starts from here with initially at rest, and it is going to reach here. Its mass is m, it is having a velocity v. So what I need to find out, find out velocity of block m when it reaches to the bottom of which. This is the requirement. Find out velocity of block m when it reaches to the bottom of a wedge. This is the requirement, and they have given this, that this is the height of the wedge. So what can I do? So for this situation, what I understand is that let's suppose this is the wedge, this is angle theta, and a block is somewhere here. Let's have all the forces that are acting on this system. It's an mg, this is theta, so that should be mg cos theta. This must be mg sin theta, and as this block is moving in the downward direction, I need to apply friction in this direction, and the normal force would be there. Yes. So this is the situation. And what is the value of friction? What should be the value of friction? The friction should be less than or equals to mu s into n, and normal and mg cos theta are equal. So friction should be less than or equals to mu s multiplied by mg cos theta. So if I understand the situation well, What I want that block is moving in this direction, that means in the downward direction of the wedge. So my mg sine theta must be greater than f, and as it is not at rest, that means it is moving with acceleration a. So what I understand is mg sine theta minus of friction, that should be is equals to mass times of acceleration, and friction is given that it would be a mu s into mg cos theta. So the situation is this is mg sine theta minus of mu mg cos theta should be equals to mass times of acceleration. Are you clear with this? Are you? Are you clear with this? So if I'm clear with this, the situation is mg sine theta minus of mu mg cos theta, and that should be is equals to m into a. So the mass has been gone, and the acceleration can be given as g sine theta minus of mu g cos theta. Yes, this is the relation. You must to remember this. This is the relation. A is equals to g sine theta minus mu g cos theta can be used every time block is moving in downward direction on friction wedge, a wedge with friction. Yes, so this must be remembered. This is to be remembered. This is very important. Yes, A is equals to g sine theta minus of mu g cos theta. That needs to be remembered. Now let's back to the work. It's an A is equals to g sine theta minus mu g cos theta. So now I have been given that my block was initially at rest, and finally it must be having a velocity v. And let's assume that this distance, this would be the x. We are going to replace it, but at this point of time you can use it x. So it should be v square minus of u square, that should be is equals to 2 into a multiplied by x. The final velocity would be the requirement. The final velocity is the requirement. Initial velocity is the 0, should be equals to 2 multiplied by acceleration, which is equals to g sine theta minus of mu g cos theta multiplied by x. So this is equals to v square, that should be is equals to 2 multiplied by g sine theta minus of mu g cos theta multiplied by x. Now how should I write the x? Because in our data x was not given. The given data was h. This was given. So what I need to do is I need to replace this. How should I replace this? Let's have a look. So at this point of time I am writing it as an x, and let's just see that this was theta that is given. We have been provided h and not the x, but we have evaluate our answer in terms of x. So what I need to do, I need to just change this sine theta is equals to h by x, and from this I can write like this. It's an h that should be is equals to x sine theta, or x can be written as h divided by sine theta. So velocity of block M when it reaches to the bottom of which is v square is equals to v square equals to 2 multiplied by g sine theta minus of mu g cos theta multiplied by x, and this x is h by sine theta. This would be the final answer. I hope this is clear. Again, this is v square, so if you want it's a v, then you need to take a square root. It's a 1 by 2. This is the final velocity. Yes? Do you understand this? Do you understand this? Yes? Same way, same way. If we are moving further in the same example that in the previous question, find out time to reach bottom of the wedge. Yes, I need to find out time to reach the bottom of the wedge. This was the situation. This was theta. It has been dropped from here. It's a u equals to 0. This wedge was with friction. This mu is given, and when it will reach at here, this is h. Yes, this time is required. So as I understood that acceleration a could be written as that a is equals to g sine theta minus of mu g cos theta. Here it was at rest, so let's assume again this is as an x, and we can write this that x is equals to half into a into t square. Yes, so this x should be is equals to half into acceleration, it's a g sine theta minus of mu g cos theta multiplied by t square. Now x in our real data that has not been given, that needs to be converted, that we have converted in the previous slide as well. It's a sine theta, that should be is equals to h by x. So x could be written as h divided by sine theta. So just replace this, it's a h by sine theta, that should be is equals to half multiplied by g sine theta minus of mu g cos theta multiplied by t square. That's it. So from here you can easily have a t square, which should be, this t square should be is equals to 2h divided by sine theta multiplied by g sine theta minus of mu g cos theta. That's it. T would be equals to square root of this, it's a 2h by sine theta into bracket g sine theta minus of mu g cos theta. Got it? Yes. So these are very interesting questions, and these are the questions that has been asked in the various competitive examinations. So key to understand this is this, it's an acceleration. Yes, so what you must understand is that if it was the case when, let's suppose I show you, yes, if this was the case that block is moving on horizontal path, then acceleration can be written as a is equals to mu into g. Yes, this was the first situation. And if the block is moving on the wedge, and this wedge is having a friction, then acceleration can be written as a is equals to g sine theta minus of mu g cos theta. If I understand well, then I must know that I have this relations, that x equals to half a t square and all that kind of stuff could be there. Yes, so that can be done. that can be done. Even a reverse question could be there. Even a reverse question could be there. Let's suppose if I change this relations, that suppose the question is let's suppose this has been certain velocity is given, something like this, that this u is not equals to 0, this is u, and they are going to tell me that what should be the final velocity v, or let's suppose ki if they have been given that velocity or the final velocity is 0, something like this, it's a final velocity that is 0. So what you need to do, you are going to do the same thing. Yes, so this is the velocity, and you are going to have a complete change in question. It's a 0 minus of u square. This is equals to minus of 2 into something like this, and this could be written as it's a u square is equals to 2 into g sin theta minus of mu g cos theta into x, because this minus minus has been plus. So can you do this kind of questions? Can you? Is it possible? Is it possible? Yes. Is it? Great. Even this time can be calculated. Yes, the same thing could be written over here as well, that this has been delivered with certain velocity u, or suppose it has been pulled and something like this. And the rest amount of things can be done. I hope this could be clear. Is it clear? Are you sure? Great. So let's see one more question, but this time it is without friction. That a wage is given. This is angle theta. This is block M. So the question is, find out. Let's say when this block was here, it was initially u equals to 0, and this is final velocity v. Find out velocity of block when it reaches at the bottom of which. So this is required. Yes, they have not mentioned that friction is there. It means they want that it is a smooth surface, so mu is equals to 0. So what do you need to do? Let's have a free body diagram of this situation. This is theta, this is m, this is mg, this must be mg cos theta, this must be mg sin theta, this is to be normal. Yes, and as mu is equals to 0, friction is absent, so friction is equals to 0. So what I understand is that if this block is moving in this direction, that is, it is moving in the downward direction, the m into a can be written as mg sin theta, because only the one force is acting on a block on that direction of motion, and block does not have any vertical direction. So you can write like this, it's a n equals to mg cos theta. If you require, you can use it. So at this point of time, I must understand that a is equals to g sin theta. This a should be is equals to g sin theta. And now relations are open for me. Yes, I can write like this, it's a v square minus of u square should be equals to 2 into a into x. This was the x, this is theta, and this is the x. Let's suppose I have been given h. So this is v square minus of 0 should be equals to 2 into acceleration can be written as g sine theta multiplied by x. This x could be replaced by sine theta is equals to h by x. And from this it is an x is equals to h by sine theta. Now even do remember this. Yes, we are not going to write this every time. It's a h divided by sine theta. Yes, this sine theta can be gone, and this is equals to v square equals to 2 into g into h. That's it. You did it. I hope these things are clear. Is it clear? Is it clear? Are you sure? Are you sure? Great. Now let me calculate a time to reach at the bottom. That could be written as x is equals to half into a into t square. This x can be written as h by sine theta, and that could be replaced, it's a half multiplied by acceleration. This acceleration would be equals to g sine theta multiplied by t square, and this t square or the time t could be written as this is 2h by g sine square theta in the square root. That's it. Yes, I hope these things are clear. Is it clear? Great. So let me have one of this summary kind of thing. Let's suppose block is moving on this, then acceleration can be written as mu into g. Let's suppose a block is moving on this. As you cannot see a friction, you cannot see the friction, that means mu is equals to 0, and this acceleration could be written as g sine theta, and rest of the thing that you understand. And let's suppose a block is moving on this wedge having mass m, yes, mass m, but this is with friction, and the friction is mu, that means coefficient of static friction is mu. So the acceleration could be written as a is equals to g sine theta minus of mu g cos theta. This is the acceleration. A is equals to g sine theta minus of mu into g cos theta. I hope this is clear. Is it clear? Is it? Great. Any concern? Any issues in this? Is there anything? No? Great. So acceleration that could be written as g sine theta minus of mu g cos theta. Is it clear? Is it? Great. Well done. So can you do a questions that is depend on this kind of concepts? So one of the favorite question, look at this. Even this has been asked in the NEET once in a JEE, that this is theta, and let's suppose that half of this wedge is smooth and the another half is rough. That means this section is with friction and this section is smooth. Suppose I release this block from here, that is from u equals to 0, and when it reaches at the bottom, it is again at rest. Let's say this section is of length x, even the remaining x, yes, because it has been told that half of them is x. So what I need to find out coefficient of static friction This is required. You require this. Find out coefficient of static friction. In this situation, it is, let's say it is mu. So how could you do this? How could you do this? Just take your time of 30 seconds and think over this, that what could be done. Yes, time up. 30 seconds has gone. What do you think? How should we do this? Let me give you the hint. Let's just see this journey up to here, and let's just write this as a V, as this is the smooth surface. So what I can write, it's a V1 square minus of U square is equals to 2 into A into X, and this V1 square is equals to, because this is 0, it's a 2 multiplied by A, could be written as G sine theta. Have you remember this? Yes, it is the smooth patch. So it's a 2 into G sine theta multiplied by X. This is V1 square. Yes. Now the rest amount of part from here to here, as it is with friction. So this should be a final velocity. This should be an initial velocity. So what I can have, it's a V square minus U square equals to 2AX. This is the master relation. And I must have, it's a 0 minus of V1 square should be equals to 2 multiplied by acceleration. Now it's a rough patch. So when it's a rough patch, it should be a G sine theta minus of mu G cos theta multiplied by X. Yes, here at this position I do not require to replace X. So I just keep it as an X. And this should be the minus of V1 square should be is equals to minus of V1 square should be is equals to, as this is should be equals to 2 multiplied by G sine theta minus of mu G cos theta into X. I hope this is clear. Is it clear? Yes. So now just what I need to do is I need to replace the value of V square. It's a minus of 2 into G sine theta into X. This is equals to 2 into G sine theta minus of mu G cos theta into X. Yes, this 2 and 2 has gone. This X and this X has gone. Yes, so this is minus of G sine theta. On that side it would be again a G sine theta. So this is what we have been left with. Let me write on the next slide. So this is the situation, is that it is a minus of G sine theta should be is equals to G sine theta minus of mu G cos theta. So it's a minus of 2G sine theta should be is equals to mu G, or minus of mu G cos theta. This has gone. This G and this G has been cancelled. So this mu should be 2 into sine theta divided by cos theta, and sine theta by cos theta could be written as tan theta. So this is equals to 2 tan theta. This should be the mu. I hope this is clear. Is it clear? Is it? Mu is equals to 2 tan theta. This is very, very important question. Please do remember this. It has been asked in previous years in both the examinations. So is it clear? Is it? Now can you do this kind of questions? Can you? Great. Now let's work for the new question. Let's suppose this is theta, and here one of the block M is given, and this has been attached with certain string, sorry. So what I need to find out, find out tension in the string. This is what they want. Find out the tension in the string. So take your time and think what could be done. Yes, this is with friction. Yes, this is mu. Let me give the data that might help you guys. This theta should be is equals to, let's suppose this is a 60 degree. This theta is of 60 degree, and this mu would be equals to, let's just change this, it's a 30 degree wedge, and this mu could be equals to 0.8. So what you can do with this, find out the tension in the string. What can be done? What I understand is first I need to check when and when this kind of questions would be there. First check whether block is capable enough to move in downward direction, if block has not been tied with string. So first what you need to consider is that first check this, that block is there, and can my block is able to move in the downward direction if no friction has been applied. Can it go in downward direction? Can it be move in the downward direction? Is it possible? So how could I check it? So what I understand is that in the downward direction the force that is acting is mg sine theta. On here it's a friction, and as I know, if mg sine theta is greater than friction, and this is mg sine theta should be greater than or equals to, it's a mu mg cos theta. So this mg can't be gone, and this, if tan theta is greater than or equals to mu, then it is able to move in the downward direction. Now what is tan theta? It's a 30 degree. So tan theta is equals to tan 30 degree. What is the value of tan 30 degree? Must be greater than or equals to 0.8. Tan 38 is a 1 by root of 3. So 1 by root 3 is whether it is like this or not. What is the value of root 3? Approximately 1.7. So if I make 1 divided by 1.7, this is 1 by root 3 is approximately it's a 0.5. So 0.5 is less than 0.8. So that means in this case this case block is not able to move in downward direction even though string has been cut. Yes, so the situation is this is theta, this is m, this is something like this. So here this block has not been stopped by the string, but it has been stopped by the friction. So there is no tension. So tension is equals to 0 Newton. Yes, tension is equals to 0 Newton because always remember this, that in this case block is not able to move in the downward direction even though string has been cut. And so here friction does not allow motion in downward direction. Is it clear? Yes. Is it clear? One more thing, and very conceptual thing, that when multiple nature of forces are acting, always apply friction first and then go for other forces. So always remember this, when multiple nature of forces, while I say multiple nature of forces, that means I'm talking about if tension is there, friction is there, normal is there. Likewise here it might possible that tension were acting, but when tension were acting, what friction is acting, tension is acting, what I need to understood is that if friction, if the applied force or the external force is greater than friction, then only tension will come into play. So first you need to feed a frictional force. If there is certain thing that has been remain, then that you can pass on to the other forces. Yes, so friction will be having the highest priority. The friction will be having the highest priority always. Yes, so shall I modify this question? Shall I modify this question so you might have somehow a certain more clarity on this? Let's suppose it's a theta, this is m, this has been attached, and this is with friction. Now this says that assume that mg sine theta is greater than, or I can say, let's say mg sine theta, yes, is greater than or equals to friction, and this block is at rest. So find out tension in string. This is the question, that now they have provided that this mg sine theta must be greater than or equals to force. That means this block has been pulled from here, and we have been given in data itself that this mg sine theta would be greater. So in this direction a friction would be acting as well as tension is acting. One more thing, it says that block is not moving, it is at rest. So what I understand is this F and T together, this F and T together balancing mg sine theta. So what I can write, it's an F plus T, that should be is equals to mg sine theta, and this friction could be written as mu mg cos theta plus T, that should be is equals to mg sine theta, and the tension could be written as this is equals to mg sine theta minus of mu mg cos theta. This is the tension force acting. I hope this is clear. Is it clear? Is it? Are you sure? Are you? Yes. So when and when this kind of situation arises, always look and always think that does it have a multiple forces? If yes, always go for friction first, and then you can move, then you can go for the other forces. But before friction, you cannot apply other forces. It would be the incorrect one. I hope this is clear. Let's work on a similar kind of question. Let's suppose a block is there, and two blocks are there. This is of 2 kg. This is of, let's suppose, 5 kg. And from here F external is there, and this is with friction. This mu is equals to, let's suppose, 0.5. So what do you need to find out? Acceleration of the system and tension in string for given F external. Yes, this is what you want. You need to find out the acceleration of the system and tension in the string for the given F external. So let's suppose F external, frictional force, a tension, and acceleration. This is what all I need. Let's suppose a 10 Newton of external force is required. Let me do this on the next slide. So the situation is, it is the 2 kg block. This is a 5 kg block. It has been attached with string. This is F external, and this is having a friction, and this friction is of mu is equals to 0.5. So what I need to do is first let's just calculate a maximum friction that can be given by 2 kg block. This is F1 is equals to mu into mg. This mu, it's a 5 by 10 multiplied by 2 multiplied by 10. It's a 10 gone, and this is 10 Newton. This is the maximum friction that can be given by the first block. A second block, it's an F2 is equals to mu into m2g. This could be written as 0.5. It's a 5 by 10 multiplied by mass. It's a 5 multiplied by 10. Again, this is 5 5s are 25 Newton. So these are the forces that has been acted. Now if I apply F external as a 10 Newton, this is the maximum friction of first block F1, and this is the maximum friction of second block. It's a 25 Newton. So let's suppose if I'm going to pull this by the 10 Newton force, please understand this very carefully. if I am applying a 10 Newton of force over here, this will be fed to this block, and this block is having a friction of 10 Newton, or maximum friction of 10 Newton, sorry. So if I'm going to pull this, if I'm going to pull this by 10 Newton, then it has been fed up. It has been fed up with this. That's why tension in the string is 0, because I'm going to pull it with 10 Newton. Here it is going to be have a friction of 10 Newton, and this 10 Newton and this 10 Newton has been gone. So nothing has been gone to the tension. So the acceleration would be 0. Now suppose if I change this, if I change this with 20 Newton, that means the next force is of 20 Newton. What would be the situation? Now let's look. This is 20 Newton. A total of 20 Newton of force is there. First 10 Newton should be fed up to this to overcome this friction, and next 10 Newton would be considered as the tension force. So this is the 10 Newton. But again, this T is equals to 10, and the maximum friction, this is in this direction, is of 25 Newton. This is maximum. I'm not talking about the friction, I'm talking about the maximum. So this system is not going to move, and this is 0. Let's suppose you have applied a 15 Newton of force over here. So this force is of 15 Newton now. So if this is of 15 Newton, 10 Newton should be fed up to here. Remaining force could be considered over here, and that would be of 14 Newton. Now what the situation is? The situation is that something like this. This force is of 15 Newton. This friction is of 10. This friction is of 25. Yes. So F net would be equals to, this is of 2 kg, this is of 5 kg. Yes. F net would be equals to 50 minus 25 minus 10. It's a 35. That is the 15 Newton. Yes. And the mass total of the system, it is of 7 kg. So acceleration could be written as F net divided by m total. So thus could be written as it's a 15/7 meter per second square. This should be the acceleration of the system. I hope this is clear. Is it clear? Is it? Are you sure? Yes. So always remember, it's a acceleration that is equals to 15/7. Yes. I hope these things are clear. Is it? So always go for the friction first, and if something left after friction has been fed up, you must go for the second forces. But the first priority would be always of friction. I hope this is clear. Is it clear? Is it? Great. Now let's work for the next question. This is theta. This is block M. This is with friction of mu. So what do you want? You want that find out force F required so that block can move in upward direction, without having any acceleration. No, what does it mean? That block should move in upward direction, but block should not be having any acceleration. What does it mean? Yes, yes, some of you might got it right. That this should be the situation that this is theta. I'm going to push this. That means from here you can make it clear. It's an F. Which forces are acting in this direction? One of them is friction. Why friction is acting in the downward direction? Why friction is acting in the downward direction? Any idea? Because your motion is in upward direction. So when it is in your motion is in upward direction, you must apply your friction in the downward direction. So this is friction. This should be is equals to mg sine theta. So if this force, that means the F external, is equal to F plus mg sine theta, then your block M would be moving in the upward direction without having any acceleration. So what I can write, it's an F is equals to friction plus mg sine theta, and this friction could be written as mu mg cos theta plus mg sine theta. This should be the external force required so that this block can move in the upward direction. I hope this is clear. Is it clear? Is it clear? Any issues? No? Great. Let's just wind it up this session over here. Yes, this was all the numericals that have combined concepts of the weight, normal force, friction, and tension force. So do one thing, do the revision of all the topics that has been started from the Newton's first law of motion. Yes, do it again and again. Yes, we are going to, on the end of this unit, laws of motion, yes, certain topics were left, only a very few topics were left, that means. So please revise it, make this very very clear, and this should be a fundamentally clear. Yes, so please practice a lot, practice so many questions. This will help us. Thank you, have a good day, take care, bye.